Welcome to Three Inquisitive Kids. This is the lesson Power of a Power, the second lesson of Chapter 7. In the first 4 lessons, we're going to be learning the Laws of Exponents. And then we're going to be learning how to use the scientific notation to rewrite smaller numbers. We're going to be learning monomials and polynomials. And then we're going to be learning integrals. And then we're going to be learning 3 different important formulas, which is the square difference formula, the perfect square formula, and we're going to be learning how to use and apply the perfect square formula into word problems. And then we're going to be working on how to divide integrals and how to divide polynomials and monomials. Our learning goals for this lesson is understand and master the power of power property, to learn how to prove the power of power property and how to use it while simplifying expressions. So we know that a to the m power times a to the n power equals a to the m plus n power. This is what we learned in the last lesson. So yes, this is the power of products power. So now we have to go into what are exponents. If the side length of a cube is 10, then what is its volume? So if you want to calculate the volume of a cube, you have to multiply its width, length, and height together. So its volume will be 10 times 10 times 10, which is equal to 10 to the 3rd power. 2. If the side length of a cube is 10 squared, then what is its volume? Again, you have to multiply 10 squared 3 times together, which gives you 10 to the 6th power, which is also 10 to the 2 times 3 power. 3. How would you express 110 to the 4th powers multiplied together? So what you have to do is you have to do 10 to the 4th power, but put parentheses around it and then add the 100th power. So this is how you prove it. And how would you simplify a to the nth power to the 100th power? Think about it. This is basically the same thing as 10 to the 4th power, but it's replaced with a and m. So in the end you would get a to the 100m power. Now let's try these 2 expressions. Pause your video and take your time to simplify these expressions. So for the first expression, a to the 3rd to the 2nd power, we have a to the 6th power, and for a to the mth to the 2nd power, we have a to the 2mth power, and remember, m has to be a positive integer. What pattern can you find in the two examples above? Compare the answer with the original expression. A to the 3rd to the 2nd power is simplified into a to the 6th power. 6 is 3 times 2. And over here in the end, we have a to the 2m power, and 2m is equal to m times 2. So over here we have a to the mth to the nth power, and then you expand it to a to the nth power times a to the mth power times a to the nth power, and there is an n number of this being multiplied together. And then that equals a to the m plus m plus m plus m plus m plus m power, and that gives us mn. If you're wondering why this says a to the m plus m plus m plus m, it's because over here we are also kind of using the product of powers property, which is what we learned in the last video. So what we just learned was the power of a power property, and this is its equation. A to the m to the nth power is equal to a to the mn power. But remember, m and n are both positive integers. So we know that the base remains the same, and the exponents are multiplied together. We learned the power of a power property, one of the laws in the laws of exponents. You can use this property back and forth. You don't always have to go from left to right. You can also go from right to left of an equation. So a to the nth power is equal to a nth. It's equal to the a mn power. And m and n are both positive integers. When you do this property, you have to make sure the base is the same and the exponents are going to be multiplied together.